Okay, we're ready to begin part B with more examples. On volume and capacity. One of them being how much is held, and that's capacity, and volume is the size of the three-dimensional shape. Again, we're going to be using unit fractions. To convert in or out. A different, I'll just say different, unit of measurement. So let's begin again. Not difficult, simply following what the protocol is, and we should do just fine. So let's look. We have a table of items. It says use a table along dimensional analysis to convert the given unit to the unit indicated. So we have capacity is in gallons, to yards cubed, which is volume. All right. So we're going to write what we know. 2,400 gallons is what we're starting with. And we want to change to yards cubed. So I notice that this entry right here is something we could use. So we're going to multiply, and we need gallons in the denominator, so it's 200 gallons equals 1 yard cubed. All right, which is what we want. So doing that, I can see that gallons cancel, and I end up with yards cubed in my numerator, which is exactly what I need. Well, this means that I end up with 2,400, 24 times 1, over the 200. This is yards cubed. So the volume that we need is going to be that division. So we're going to do the math. So we need 12 yards cubed to take care of the requirement of containing 2,400 gallons. That's a lot of something, right? So we're looking here at volume and capacity specifically with metrics. From volume to capacity. So again, we're looking at 1 liter to centimeters cubed. So we're looking at capacity to volume. How much will we have to build to contain that 1 liter? So in this one, I see this right there. Very nice. So we're going to be using that one. 1 liter. And I need the 1 liter over the 1,000 centimeters cubed. All right, so let's verify that the liters cancel, and I'm left with centimeters cubed, which is what the request was. So if I multiply, then I'm going to end up with 1,000 centimeters cubed. So that was easy. Now let's look at this. Now we're talking capacity to American to metric. All right. So let's see what we have here. And we have a selection: a teaspoon, tablespoon, fluid ounce, cup, pint, quart, and gallon. And over here we have milliliters, 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 liter, 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 liters. All right. So we're going to use the English and metric equivalent for capacity along with dimensional analysis to convert the given units to the units indicated. We want 65 milliliters, which is metric, to fluid ounces. All right, so the only fluid ounces I have is this guy right there, and it fits the bill. So I'm going to write that 30 milliliters is equivalent to 1 fluid ounce. All right, so the milliliters cancel. I multiply across. I'm going to get 65 over 30 fluid ounces. All right. So now I'm going to use my calculator. I could do it in my head maybe, but why embarrass myself with the wrong answer, right? 65 divided by 30, and I get 2.1666 dot 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 forever. And they run 2 decimal places. So that means it's approximately 2 1700 fluid ounces. All right. Okay. So we're nearing the end of this section. It's more language than anything else, and it's important that we read. Now, what I'm showing you next is from drop-down windows that are in the homework as well. That'll be a little square where it'll tell you click, and you can see the information. It says population density. And so that means how many people per area, whatever the area designation is. A bar graph shows the resident population and the land area of a particular county for selected years from 1800 through 2019. Use information to compute the questions. Well, we can see that it has steadily increased. The blank one is the population, and the land is the dark one. And the land has also been increased, but on the population, it is almost linear. I mean, it is interesting. All right. So here are the actual figures below, and that's what we'll be using. And that's what we need to get what were the answers to what we're working. So here we go. Here we go. It says, find the population density of the county to the nearest tenth. Tenth is what? 1 decimal place. In 1900 and 2019. So that means people per square mile. People per square mile. All right, so we're going to construct 2 ratios or units. All right, so I'm thinking I'm doing it. Okay. Sorry, it's population per square mile. Population per square mile. So in 1900, we need population per square mile. All right, now we're going to make that ratio happen. In 1900, the population was 75,904. I'm sorry, 1,940,245 divided by our land, which was 2,911. And now we're going to do the math with the calculator and to the 10th. All right, so this will give us 75940,245 divided by 290,011. Let me see if I have it all right. 75940,245, 29 zeros, 11. Good. Enter. And I get that's a good one. 26 26 point, okay, so I'm going to write it as 26.1861, and we want one decimal, so that would give it to us as 26.2, and we would write it as people per square mile. All right, so that takes care of that year, and then they want 2019. All right, again, we're looking at population over the square miles. And this gives us, in this case, we're talking 281,433,259 divided by 3740989. All right. I think I have it. Now the key is, can I do it on the calculator without making a mess? 281, well, the verdict's still out. 33,259. 281,433,259 divided by 3740989. Enter. All right. Well, we can see that, let me get this, move this aside. That what happened here is we have the number 75.2296 forever. We want one decimal, 75.2 people per square mile. All right. So we did the two things they asked. Now they want us to find the percent increase in density to the nearest tenth. That means one decimal of a percent. And percent means we multiply by 100. Whatever the fraction is, we multiply by 100 and add the percent symbol. All right, so we want the difference. So we're talking 2019 minus the 1900, and these are densities. Over the initial. All right. So now that we have that, we can construct our problem. Again, we're going to have the 75.2 people per square acres, people, minus the original, which was 26.2, divided by the original, our starting point, because we're trying to measure the increase. And we can do it all on calculator. All right. So we're going to open with a parenthesis and then enter the 75 and 2 minus the 26 and 2 and then we're going to close parenthesis, hit the divide sign, and then enter our initial 26.2 and enter. All right, here we go. All right, so let me get my calculator closer so that you can see it. There we go. And I'm going to have open parenthesis, which is the 1, 2, 3, 4, 5th row, third key, open parenthesis, oops. And I'm going to put the 75.2 minus the 26.2. Oh, look, I forgot the 2. Second insert, I'm going to put the 2. All right, and then I'll move this over. Close parenthesis divided by 26.2. I've got to double check. Open, close, divide. All right, so I'm going to enter. And I get, oops, sorry. So now, let me make some room. And I can write what I got as an answer. So what an answer is 1.8702, blah, 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 blah. All right. So what we want is percent, because this is a mixed number. So I'm going to move the decimal over 2 places to the right, and I'm going to say 187.0%. So it's 187. The 1/10 of a percent. All right, we're doing it. We're doing it. Okay. Now, we're going to talk about another type of problem, and we're going to figure out if it is something we can do that measures hectares is for sale. How large is the property in acres? All right, hectares. And I think I erased it by mistake. All right. Sorry about that. I'll have to look at my notes and tell you what a hectare to acres is. The identity is 1 acre is equivalent to 4/10 hectare. So that's what we know. So here I go. I'm going to write 14 hectares metric, and we're multiplying by 0.4 hectares is equivalent to 1 acre. All right. So I'm going to do my cancellation of hectares. I end up with acres, which is exactly what I wanted. So that would be 14 over 0.4 acres. All right. So now we're going to do our calculator. And I get 35. So I have 35 acres. That's equivalent to 14 hectares. All right, so now they want to sell the property for $450,000. What is the price per acre? Well, we have 35. So 450, 1, 2, 3, cost divided by acres. So now I'm going to use my calculator. And I get 12857.142 dot dot dot. Okay, so that means 12,000, sorry, $857.14. per acre. That's a lot of money. All right, so we've completed section 9.2. And we have one more in chapter 9 to complete. Make sure that you took plenty of notes, and if you have any issues, make sure you contact me and we'll see what we can do. All right, thank you very much for listening. I'll see you for 9.2.